Team Globulocytosis. We are students of Manipal Academy of Higher Education, Dubai. For the second edition of Emirates Robotics Competition 2024, we are participating for the third challenge, Water Cleaning Surface Robot. The team members in this team are Jaron Jose, Mohammed Ahmad, Bilal Baislar, Saji Razak and Medwin Verghese. Our surface water cleaning robot hoping to slice through the competition with a nimble vectored frame, collecting trash with a smart rotating rod and AI-powered obstacle avoidance. No red balls fool us, only green and yellow treasures end up in our targeted disposal bucket. Pixhawk brains and Jetson Nano brawn powered this aquatic marvel. The Pixhawk 4 acts as the robot's central nervous system, handling navigation, stabilization, and motor control. It receives commands from the Jetson Nano and translates them into precise thruster adjustments for smooth and accurate movement. The Jetson Nano serves as the robot's intelligent brain, responsible for processing sensor data, running AI algorithms for object detection and path planning, and making real-time decisions about movement and actions. The HD camera is connected to the Jetson Nano. 6 thrusters which were 3D printed give 6 DOF control and efficient movement which will be helpful in turbulent waves. BLDC motors are used in the thrusters. The motors are then connected to bidirectional ESCs, which are then connected to the Pixhawk to receive instructions. The collection mechanism has 2 parts. One is the rotating rod with fins to gather trash items. Second is the conveyor belt for transferring them to a collection bucket. The disposing mechanism is using 2 servo motors to rotate the bucket at a length for targeted disposal of the collected trash. This is a prototype of a model we made in which both the collection and the disposing mechanism is combined. We then realized it would be better to separate them for efficient working. For the safety of the electronic components, we are using a filter housing to make the waterproof enclosure for Jetson Nano, Pixhawk, ESCs, motor drivers, and batteries. We are also using a 30 ampere fuse for electrical protection. We are using 11.1 volt 6000 mAh 60C LiPo battery with XT90 connectors. For the software we are using ROS Melodic Functions as a flexible operating system that interconnects the hardware components, allowing them to communicate and share data seamlessly. It enables the Jetson Nano to send commands to the Pixhawk and receive sensor readings, ensuring coordinated operation. Mavros bridges the gap between the Jetson Nano and the Pixhawk, providing a reliable communication protocol specifically designed for robotic systems. It ensures accurate data exchange and command transmission, fostering a harmonious partnership between the robot's brain and body.
For object detection we are using YOLO V5, which is trained to distinguish between green, yellow, red balls and the disposing bin for navigation strategies. It feeds real-time object recognition data to the path planning algorithm, guiding the robot's actions. The path planning algorithm is run by convolutional neural networks using the ResNet 18 architecture on the Jetson Nano using PyTorch and Torch2 TRT. Currently in hardware we have individually tested each thruster underwater and is giving 1.8 kilograms force of thrust at 12 volts. For the collection prototype we are currently building the conveyor belt. For the disposal prototype we are working on the construction of the bin and links to the servo motor. In software ROS nodes for ball tracking has been implemented using Python 3. The Pixhawk has been tested with all the thrusters. We have to now integrate Pixhawk with Jetson Nano using Mavros. In the span of the next few weeks we have to finalize the collection and disposal mechanisms and build the robot hulls and integrate hardware components. Thank you for listening and we are hoping to achieve the best in this competition.